Hello there. Good morning, good afternoon, good evening, depending on the part of the world you are listening to me from. You are welcome to another lesson on Bed Series Biology Explained This. I still remain your biology teacher, Peter Sabiodun, and in this lesson, we'll continue our discussion on enzyme inhibition. Still waiting to hear from you on your experiences and your understanding of the concepts we discussed in the first lesson on inhibition. So, in this continuation on inhibition, we'll be discussing the different kinds of inhibition and other things around inhibition concepts. So, come along and let's enjoy this ride together. Now let's look at our learning objectives for today's lesson. Okay, remember it's a continuation from lesson one. So this one, at the end of this lesson, you will be able to describe what is known as uncompetitive inhibition and be able to describe end product inhibition. Very interesting stuff there. And of course, another interesting concept, zymogens. And you should be able to describe reversible and irreversible inhibition, and at the end of the day explain the effect that inhibitors have on Vmax and Km, and of course be confident and bold and courageous enough to apply all these concepts and principles to questions so that you can excel in all your examinations having clearly understood these concepts that we'll be discussing. So let's begin by discussing what is known as uncompetitive inhibition. So now, in this context, very interesting thing here, this one does not bind to the enzyme alone. Now, if you look at non-competitive inhibition, it requires you to have the enzyme molecule being available for it to affect. Okay, now a difference that you have to understand between non-competitive and uncompetitive is that this one binds to the ES complex. It's like waiting patiently for a man and a woman to marry, and then you begin to interfere with the marriage. So you saw the lady on her own, you didn't do anything. It was when she got married that you began to disturb her, or it was when the guy married that you began to disturb her. So it's like when you have had a coupling, so the enzyme had identified the substrate, they formed ES complex, and suddenly this uncompetitive molecule binds to them and begins to have a problem, because if it binds to you, instead of having the ES complex, what you now have is the ESI complex. Very funny stuff there. It's a great disruption here. So it's what it does is that it disrupts, it involves, or let's say put this way now, okay, for your clear understanding, usually disrupt reactions in which you tend to have two or more substrates or two or more products that are available. So unlike when you had the uncompetitive situation, okay, which can occur without or with the substrate, this one will always require an ES complex. That's a very important difference that you have to note in this discussion. So if you have, look at this diagram, you're seeing that the substrate had been bound to the enzyme before this inhibitor came to attach itself to the complex that have been formed already. And so let's go on to end product inhibition. Remember, we just came from uncompetitive situation. You can have a non-competitive inhibition with or without the substrate. The inhibitor that is called non-competitive can just bind to the free enzyme, okay? But a substrate must always be available for you to have an uncompetitive inhibition, because it binds to the complex, not the enzyme alone. So let's look at a very interesting kind of inhibition, which is known as end product inhibition, or you can refer to it also as feedback inhibition. And what happens here is this: you have an instance where the end product of a metabolic pathway inhibits the very first enzyme in the pathway. Let's look at a scenario here in our mind's eye. Just go with me and begin to think with me. You have a pathway where A is converted to B, B is used to form C, C forms D, and D forms E. So if you look at A, B, C, D, E, the whole idea is for A to become E as the final product. B, C, D were intermediate products. Let me say that again. A pathway, like I've said in previous lessons, if you watch the video on enzyme activity, we talk about pathways occurring in cells. No reaction is in the cell occurs individually. It's a matter of many small steps making up a pathway. Like we used the example of glycolysis at that time in that lesson. Glycolysis has 10 steps just to break down a 6 carbon molecule to 2 molecules of 3 carbon atoms each to form glyceraldehyde. Okay, and then you've now formed pyruvate. Just to form pyruvate, that's all the idea of 10 steps. Just to form pyruvate and then form NADH and then form just 2 net ATPs. That's the whole idea about 10 steps. But there are reasons why reactions can never be just one step like that in cells. So here, in this case, the purpose of an end product inhibition is to control the rate of production of the products. So if you are forming products that you are not using, it's a waste of resources. Now, if you are producing proteins, for example, energy is being used because ATP is required for biosynthesis. Every production process will use a lot of ATP. And then you will need raw materials like amino acids to produce the proteins. So you are using so many resources in the cell to produce proteins that the cell doesn't need. So the moment the products are becoming many, you begin to have the product, the final product, which is E in the pathway I painted a picture of in your mind's eye. E now goes to inhibit the first enzyme. So let's say the enzyme between A and B is E1, between B and C is E2, between C and D is enzyme 3, and between D and E you've got enzyme 4. So you've got enzyme E1, 2, 3, 4 respectively between the different reactions making up this pathway. So what you have is that the product E inhibits enzyme E1. What happens in end product inhibition is that the final product of the pathway, not those intermediate products, okay? The final product inhibits the very first enzyme in the pathway. So in the picture I'm painting in your mind's eye, E1 is the first enzyme because it catalyzes how A is converted to B, which is the very first product in the pathway. And it's very important to understand, just like when companies that take stocks a lot, Q1, meaning the first quarter, second quarter, you review your performances as a company. If you targeted at the beginning of the year that you're going to make X number of sales, at the end of Q1, the first quarter, that is March, you come together, this thing that we have produced, what's our sales like? Of course, by the time you are rounding off the year, you are going to take a stock. When you begin to see that you have produced so much and the sales have dropped, that's why you see companies being very nice around November, December. You can say buy one get two free, not because they are nice, they are clearing their stock. It's just common sense. When you have made so much of production and there is no purchase or sale, your stores are full of material that you produced and you have tied down money, you have tied down resources. So much is tied down in your store and there's no purchases from anybody. And then you want to produce more, of course, it makes absolutely no sense whatsoever. So that's the picture here. The final product inhibits the very first enzyme in the pathway. And still on end product inhibition, okay, it's utilized by cells to regulate metabolism. So it's not a negative thing. It's like a negative feedback because you are counteracting production that is too much because it's not being controlled. So when the cell does not need the quantity you are producing, there's a need to try to slow down. And the interesting thing about this pathway is that the moment the product is now being used up by the cell, that kind of inhibition is automatically switched off. Very interesting. That's why it's a very important regulatory process in cells. The moment the end product is now being used up by the cell and its concentration goes below a particular level, automatically the inhibition that the final product had on the first enzyme in the series is automatically withdrawn. And so you are seeing examples there that the cells control production of some substances that the cell does not need in the quantity in which they are being produced at that time. And so let's talk about a very important kind of substances, or let's say concept called zymogens. Okay, now when we talk about regulatory proteins, we usually think that they are roving around doing stuff like that. It's erroneous, very, very wrong. Imagine an enzyme that's always active in the cell that produces it. That enzyme will even digest the cell that produces it. Very nice stuff. Just take it like that. So enzymes are usually produced in an inactive form called zymogen. Okay, so regulatory molecules are not always left to act on their own. Just imagine having a sword or a knife without putting the sword in a sheath. Even you carrying the sword or the knife, you can be harmed if it wrongly touched the metal, that is the blade of the knife or the sword. Just imagine having a gun that you don't put in the holster, and then it was already. Why do you think that you uncock your gun? It's when you want to fire a shot that you cock the gun. So there are safety acts that have to be ensured. Yes, this substance is needed, but if it is not needed at the time it was produced, you've got to keep it in a form that it is safe. Another thing is that if you are transporting that regulatory molecule over a distance, you don't want it to act on the way until it gets to where it is going to be needed in that metabolic process. So you package that molecule, that enzyme, or that kind of regulatory substance in the inactive form called the zymogen. It's when it gets to where it will be used that it will be activated to now become functional. So it's very important to remember that zymogens are inactive forms of enzymes and other kind of regulatory proteins. And still on zymogens, you have an example there. The common enzyme we talk about, trypsin produced by the pancreas, by the acinous cells of the pancreas as an organ. Now, chymotrypsin, okay, now this particular enzyme is required, so we need trypsin to work, but then what you have is that chymotrypsinogen is what is produced from the pancreas. Okay, now rather than having your free trypsin, it is in the form of the zymogen called chymotrypsinogen, which is an inactive form of trypsin. So when the trypsin is transported from the pancreas through the pancreatic duct to the duodenum of the small intestine, that is when it is now activated by trypsin, by cleavage. So chymotrypsin will not work. So your chymotrypsin was produced, packaged in the form of chymotrypsinogen, and when it gets to the duodenum, is now activated by trypsin. So it is now, the amino acids are added. Usually the packaging of a zymogen is to add extra amino acids to the chain of the peptide chain of that protein structure. And so when you get to the site of the action of that protein, it will be, you remove the excess amino acids and then you activate the protein that is required. So remember, zymogens are like a safety act where you keep the molecule in a form that it cannot do more than it's needed. Otherwise, enzymes can likely digest the cells that produce them. So we come to reversible and irreversible inhibition. Now, there are instances where the kind of bond formed between the R groups in the active site and the substrate molecules can lead to reversibility of that inhibition. You can undo what has been done, and there are instances where there's no hope at all. That's what we'll be discussing under reversible and irreversible inhibition. And so, reversible inhibitors usually bind by means of non-covalent bonds to the active site. That's what they do. Okay, they bind using weak bonds like hydrogen bonds, ionic bonds, and then of course weak hydrophobic interactions. Meaning, simply put, those kind of inhibitors, they bind by means of non-covalent interactions. So, because these bonds are weak, they can easily be weakened. They can be broken rather, because they are weak bonds. They can be broken, and so the inhibition that those inhibitors caused can definitely be undone. So that is the basis of the reversibility of that kind of inhibition. But then on the other hand, when you have this kind of inhibition where the inhibitor binds by means of covalent bonds, usually it's a permanent bond that can even alter the 3D shape of the protein structure of the enzyme molecule. In this case, once the bonds involved are covalent, usually the inhibition is irreversible. So what you should take away are this. One, you can have non-covalent bonding, which leads to reversibility of the inhibition, and you can have covalent bonding, which ensures that there's usually the, the, it becomes unlikely to undo that kind of inhibition. And so, before we round off, let's look at the effect of inhibitors on the Vmax. Vmax is the maximum rate of the reaction, and Km is the amount of substrate required, that is the substrate concentration required to produce half of the maximum rate. You can see now competitive inhibitors, because if you increase their concentration, they can eventually reach the maximum rate. So you see those three curves there. Initially, when the substrate is low in concentration compared to the inhibitors, the inhibitor that you call competitive inhibitor has the upper hand. That's why the reaction rate was slow at the beginning. And with increasing substrate concentration, it becomes possible to attain Vmax. So in competitive situation, what you have is that the Vmax remains the same, but because more substrate will be required, you are going to have a higher Km. So in competitive inhibition, Vmax remains the same, but Km increases. Now the converse is different. What you see in non-competitive inhibition is that because this inhibitor does not compete with the substrate for the active site, definitely the Vmax is never attainable. So Vmax is lower, and of course, increasing substrate does not change the kind of inhibition that we refer to as non-competitive. So if you have non-competitive inhibition, the Vmax is lower because it's not attainable, but Km remains the same. This particular concept is needed to be understood because in exam, it's a common question that examiners ask, and if you are an advanced student, this is very important for you to note. And so we begin to round off by looking at our self-assessment subjects. Go through these questions. You will see that there are a couple of questions that are not direct, particularly for advanced level students who are sitting for Cambridge examinations. You will need to go through these kind of questions for your understanding and review of the concept you've learned in your AS examination. So in your AS syllabus, you studied enzymes, and so these questions are application knowledge that you have. They are testing your knowledge, so they are not like asking you to define this, define that. They are questions that are based on application of your knowledge. So you have to go back to your text and also review the videos over and over again to be able to answer these questions. And so at the end of it all, I will expect your responses, your comments, your observations, whatever it is. Please get back to me. Get in touch through these addresses on the board: WhatsApp number, email, Instagram, and the YouTube. And of course, I am available to do online teaching. If you want me to be your online tutor, it's very, very simple. Just get in touch with me. We will discuss the modalities, and because we look at our timetable, our schedules. When we are less busy, we can work together towards that examination. So if you want online tutoring, I'm available to help. And so if you have comments, observations, and whatever on the questions at the end of these lessons, or you have things that you want to clarify in terms of biology, please get in touch. I'll be willing to listen to you, attend to you, and then we work together as partners towards your success. Remember, we are here to help you, and you can go together. So please get in touch, and we will work together as partners to your success. Wish you the best in your examinations. Have a wonderful time, and please tag your friends, like and share these videos so that many more people can get to learn more and be more confident as they approach the examinations. Remember, our slogan here is that nobody needs to fail. Everybody can do well with the right kind of mastery and understanding of the concept and principles. See you in our next lesson. Bye.